So, ever since the advent of artificial intelligence, 3D creators have always asked for a UV AI tool. And of course, we've seen a couple of cool AI tools that can actually create 3D models from images all the way to texturing them and adding some interesting high-quality post-process effect on animations by simply using a viewport input. And we've also seen some cool AI tools that can actually read characters and do it very well. I mean, we've also seen some 3D tools that actually goes as far as generating 3D animations, and we've actually explored a lot of these on the channel. But one thing which we haven't really seen is an AI tool that creates UVs the way a professional would. And for as long as 3D has existed, UV unwrapping has been quite the villain of the creative pipeline. Of course, there are various tools that you can use to mitigate this and make it a bit more easier for creators to work with, as without UVs, layering your textures may not necessarily be the easiest of things to do, except you rely on PTEX, which is currently available in some tools like Maya, Modbox, 3D Coat, and a few others. Other than that, you definitely need UVs to get that usable texture on that model that you've just made. And artists have definitely built a lot of careers just simply avoiding this. Studios have also built some tools to sort of tame this, and yet this process still remains stubbornly manual, technical, and extremely time-consuming. But today we have some interesting news, as the Shenzhen University alongside the Simon Fraser University and the corresponding author have worked hand in hand to make life a bit easier for creators, introducing MeshTailor. And MeshTailor is the first mesh native generative framework designed to cut UV seams the way professional artists do. In this case, this isn't doing it manually, but automatically, consistently, and in seconds. This doesn't rely on projections, all those technicalities that typical artists use to bycut a few process. It doesn't guess, it just simply understands mesh and understands how to cut it. And this is that kind of shift that creators have been looking for a long time to improve their workflows, and once implemented as a main tool, will reshape how creators work with 3D models moving forward. And how this works is pretty interesting. So given an input mesh, this gets encoded in two streams. The first one gets to build the graph with a graph encoder. And of course, there's also the point sampling that is done by simply using the point cloud sampling. And the point cloud sampling, when plugged into the point cloud encoder, yields and produces global shape tokens. And so these two together are fused within the transformer block to get the cross attention, and this is used to produce the global context to each vertex. And from there, the transformer decoder collects those points and is used to select the vertex, which is used to do the seam serialization / sequential cutting. And with this method, this now produces a series of seam chains. This makes a lot of sense because via this method, UVs are being placed properly, and in terms of texturing or even flattening out the UVs, this is also going to be represented in the most professional way possible. And in terms of complex mesh, where you do have various poles, this also works perfectly in that regards, as this also offers a very interesting system that restricts how the movement of the seam cutting is. All of these are done to produce nicer results when cutting your seam or using this tool to do it. And if you take a look at what this looks like alongside various other tools that has actually attempted something like this before, it is quite interesting to see how this one stands out. And there's a couple of examples that also get to do with the UV chat comparison on garment code data and also on text verse. Of course, you can also take a look at what the decision looks like on both the garment code data and the text verse as well, and you can see how this stands out. You can also see some tools that are very close to actually getting something pretty nice, like the Path UV, but for the most part, this doesn't handle seam cutting professionally as MeshTailor handles it. And if we go all the way down, you can also see the UV quality under a tiling strip texture. We can see what Upcuts looks like, Zatlas, Nuvo, Blender, Path UV, and currently the MeshTailor. And by every means, of course, these are doing the best that they can, but MeshTailor seems to be more closer to professional seam cutting that can be pretty useful for artists than the rest of these other ones that are right here. Going all the way down, you can see what production-oriented UV usability currently looks like, and you can see this across different tools as well. These tools are doing the best that they can, but of course you can see how MeshTailor handles this. And in terms of the loop-induced path decomposition, MeshTailor naturally produces loop cuts as part of the seam structure. At the same time, the robustness to vertex noise is also something that is here. So at this point, this is currently as a paper, and for those who like to read up on this, you can simply come through and check it out. One of the cool things that they did mention about this, which is part of the process of their inference, is the divide and conquer, as this is one of those interesting inferences that is being used to divide the mesh into subsections that would allow MeshTailor predict the accurate seaming, which will now lead to cleaner and nicer looking UVs. And of course, this is amazing. So this is it. MeshTailor currently is still a paper, and potentially we might be having our hands on the code pretty soon. And hopefully this gets implemented in some of these tools that we get to work with every day. And this is definitely going to help artists in the long run, as this is one of those bottlenecks that artists get to deal with, and having a tool like this, or even having something like this that can help cut out that time that is used in doing UVs, is a welcomed idea. Tell me what you guys think about this one in the comment section. And of course, if you like this video or you learned something from this, you can go ahead and give a like, and don't forget to share with a friend. And until I see you guys in the next one, peace.